This is the first video of PLC Programming video series. This video has been developed by Dr.Sanjeewa, Senior Lecturer, University of Vocational Technology in Sri Lanka. Introduction to Automation. In order to survive in industry, companies comparatively increase flexibility, quality, cost optimization, efficiency, etc. As a result, automation technology has been introduced for most companies in the manufacturing industry and process industry. Actually, it is a combination of control system and information technology. In automation, machines and systems are operated without significant human involvement. Therefore, automation technology reduces human activities in the industries. As an example, before the automation, vehicles were manufactured by workers. Both skilled and unskilled workers were involved with the manufacturing process of vehicles. After introducing the automated production line, a vehicle has been built with minimum workers. Now, automation plays an increasingly important role in the industry. Earlier, relay-based control systems were used in automation. Relay-based control system has to be hardwired to perform. If the system is required a modification, wiring system has to be modified. It was a particular problem to the automation industry. In addition to that, relay-based control system required a large space to be used for electromagnetic relays. First programmable logic controller was developed to replace relays and relay-based control systems in the 1969s. It was a solution for much more hard wiring required by relay-based control systems. A PLC can be programmed as a replacement for 1,000 relays in a relay-based control system. PLC is an industrial-graded computer. It has a programmable memory to store the instructions and to implement functions which are used to control the automation systems. PLC can perform logic, counting, timing, sequencing, arithmetic. The PLC is a small control device that can be connected directly to such devices as voltage and current sensors, thermocouples, resistors and resistance thermometers, switches, two-wire proximity switches, solenoid valves, contactors, low-power motors, lamps, and motor starters. The PLC is built to withstand the industrial environment. Troubleshooting and modification of the control logic can be completed within short time period. Advantages of PLCs. Key advantages are discussed here. First advantage is flexibility. As I explained, modification of the system with PLC-based control systems easier than relay-based control system. In relay-based control system, relationship between the inputs and outputs are obtained by the wiring. But in PLC-based control systems, input devices and output devices are separately connected with PLC. The relationship between the inputs and outputs are obtained by the user program. Next advantage is quick response. PLC-based control system can be used for high-speed automation systems. As an example, counting process of the high-speed production line required quick process of the controller. Therefore, PLC can be used with high-speed production line. Reliability. PLCs increase the reliability. PLC program can be written and simulated without hardware components. If any error or mistake is observed, program can be modified. Finally, accurate version can be downloaded to PLC. As an example, Step 7 software is used to write program for the Siemens S7300 PLC. After writing program, it can be simulated using the Step 7. The accurate version can be downloaded to the S7300 PLC. Components of the PLC. PLC consists of following components: power supply, central processing unit, CPU, input module, and output module. Externally, programming devices can be connected to the PLC. Power supply module. This power supply module in PLC is used to supply the power to the CPU, input modules, and output modules. Normally PLCs have 5 volts DC power supply. Central processing unit. The central processing unit, CPU, is the brain of the PLC. CPU receives signal from the different types of input devices. Then it will be processed by downloaded program in the CPU and send command signal to the output devices. Sizes of the PLCs are vary with the size of process to controlled. Small PLC which has limited memory is required for small scale automation. For the large scale automation, large PLC with more memory is required. Some PLCs can expand the memory. Many PLCs come with a battery backup that is useful to keep the program in the memory during the power failure. Battery backup supports to keep the program from 1 month to 1 year. Siemens PLC provides battery backup with CPU 313 and above versions. Input and output modules. Input modules and output modules of PLC provide interface between field devices and CPU of the PLC. CPU receives information from the input devices via input module, and CPU send information to output devices via output module. Input and output module may be analog or digital. Discrete type sensors such as limit switch, photoelectric switches can be connected with digital input module. Discrete type devices such as relays, light, and solenoid are connected to the digital output module. Some PLCs come only with digital modules. But in practical scenario, analog input and analog output devices are used with automation system. If it is required, a PLC with analog module or expansion analog modules can be purchased. The analog input module comes with one or more analog to digital converters. Therefore, analog input devices can be connected to the programmable logic controller directly. Measuring voltage or current from analog devices is converted into 8-bit or 12-bit or 16-bit digital word. The analog output modules come with digital to analog converters, allowing the PLC to send analog signal to the analog devices. Siemens introduced different types of expansion modules. Here consider few of them. Analog module from Siemens. SM331 analog input modules. For the connection of voltage and current sensors, thermocouples, resistors, and resistance thermometers. SM332 analog output module. For connecting analog actuators. SM334 analog input and output modules. For connection of analog sensors and actuators. Digital module from Siemens. SM321 digital input modules. For connecting switches and two-wire proximity switches. SM322 digital output modules. For connection of solenoid valves, contactors, low-power motors, lamps, and motor starters. SM323 digital input-output modules. For connecting switches, two-wire proximity, switches, solenoid valves, contactors, small motors, lamps, and motor starters. PLC provides flexibility to connect several input and output modules. All modules can be mounted on rack. There are no specific slots in rack for the module. The rack has capability to accommodate any module with any slots. Remote units. If distance between input or output devices with CPU of the PLC is high, large amount of wiring required. In order to minimize required wiring, a special rack which is called remote rack can be used. Remote rack supports to locate the input and output modules nearby the devices. A communication network with communication modules is used to communicate with the remote modules. Types of PLCs. According to the arrangement of the input and output modules, PLC can be categorized into two groups: fixed PLC and modular PLC. Fixed PLC is a small unit. It is a compact version. All components of the fixed PLC come as a one unit. Fixed PLC doesn't have removable unit. Limited input devices and output devices can be connected with the fixed PLC. Modular PLC comes with separate modules. All components can be mounted on rail. When you designing the automation system, PLC can be purchased based on the number of inputs and outputs of the system. Later, expansion is required for the system, input and output module can be purchased.